I think everybody's here today, but just in case I'm recording, some of you sometimes don't have all the homework ready. So for those of you just joining us, there's number 14 going in evenly, final answer of, you can see. And then number 30 did not go in so evenly, remainder was 199. All right, here we go, number 40 and 60, some more synthetics, right? Did you get your zeros in to save the spaces on number 40? If not, you would have had some issues. But it does go in evenly, it meaning x minus 9, and it goes in x squared plus 9x plus 81 times. Why are they doing this weird x can't equal 9 mumbo jumbo at the end? Yeah, it's giving you the 0, and it's saying, okay, even though this can become that, we have to remember back here, since there was a denominator originally, that 9 is not allowed. It's a domain problem. When we divide, the domain problem disappears, but it's not truly gone, and we have to write it to remind ourselves of that. Number 60 had to hold the place with a 0 also. You can still see the answer up here to number 40. Number 60 went in evenly also, but this one was one of those show the factors. What? Since it went in evenly. This cubic polynomial divided by x plus 4 equaled x squared minus 4x minus 12. So I could multiply that x plus 4 to the other side and have the full factoring of this polynomial. And have the full factoring of the polynomial, whose zeros would be, oh, hey, if I know that, -4, -2, and 6. Oh my goodness, that was the end. I think I gave you nasty ones in the odds, but not the evens. All right, do we have any homework questions? I'm ready if you're ready. Anything we want to ask, odds or evens from last night? Justin. To number, which one? Got him. Anything else you guys need to see or ask, odds or evens? 57. Which, same one. Ivy doesn't like 57 either. 57's the worst one? Yeah, Keela. 81? 81, 57 going once. 81, 57 going twice. All right, here we go. 57 is the first one that comes up, and he is remainder theorem. Oh, gross. We had to plug all of those in? Wait, I thought plugging in was easy. I thought plugging in was like chapter 1 stuff. What are you supposed to be using? Yeah, hold on. Even if you like totally aced this problem, you're like, it would be easy. Even if that's true, okay, I'm holding a Sharpie. This is so bad. You're a smart board. Okay, in section 2.5, pause. Where are we going today? Section 2.5. And 2.4 back there says we're going to. Oh, you guys already took notes, didn't you? Complex. Oh, wrong one. Complex numbers, right? We're timing out and doing division in, or we did time out and do division in 2.3. We're timing out and doing complex numbers in 2.4. And then in 2.5 we come back. There's a reason I'm saying this. In 2.5 we come back, and when we come back to big old nasty polynomials where they say factor, and you're like, A strategy to factoring something that's going to help you out is having a way, guys, check it. Having a way to do things like number 57 quickly. Some of you, plugging in is the way to go. It's the way that's best on your brain. Literally, plugging in is better. But some of you, synthetic is better. And some of you are going to have to do both, or doing both will help you the most. In math, there's multiple ways of getting to an answer. Not always, and not always going to a right answer, but there are multiple approaches. And part of that is your strength, is your creativity and your own unique bent as far as what's better for you. So anyway, I know that these are nasty, but in section 2.5 it's crucial. And specifically, these ones are the most helpful for section 2.5. Because you guys see what your last constant is? What are the factors of 4? Well, 1 and 4 are 2 and 2. Positive and negative, positive and negative. If I can find a 0, if I can find one that works, a factor, I can break it down with synthetic. So to be honest, some of you, you're a lot better at mental math. You're like, hey, that's 8, and hey, that's, oh, shit, I can't talk about it at the same time. That's negative 20. And hey, that's negative 14, and hey, that's 4. So negative 20 and negative 14, that's negative 34, negative 34 and 12, that is not 0. That's what's helpful for section 2.5, whether or not it's 0. But some of you, to be honest, plugging numbers in and doing it quick is not your strong suit. So to that end, it would be a lot better for some of you just to do the synthetics. And so to do the synthetics, you can have your 1, you can have your -5, your -7, and your 4. You can plug in, like for letter A, you would plug in the actual value. Now this is pointing to h of 3. It's pointing to, does x minus 3 go in, but you're plugging 3 into the box. Then it's a quick multiply, add. If I can multiply and add right, I'm a little paranoid. Okay, there we go. And then we have -39 and negative. What were they asking you for? H of 3, right? Wouldn't h of 3 just be -35? Are we okay? People that asked on 57. Was there one of these that was worse than the others, or was it just the general idea of what you were supposed to do? Because you could keep doing synthetics. -5 is pretty bad. I think I already plugged in 2, so technically I just said a second ago, and maybe some of you could run with that. It's not horrible to actually get really good at plugging and chugging also. I think I got -34, -30, -22. Was that me? H of -2, maybe I'm getting a little nervous about what might happen if I keep on doing a lot of mental math while I'm talking. So let me go ahead and just do it easily. That would be 14, that would be 7, that would be -14, and that would be -10. And then Sid said that -5 was nasty. You have to be really good at your positives and your negatives, addition, subtraction, multiplication. When we have 43, and then 5 and 3 is 15, carry the 1, 21, that's a negative number, and that's negative. Ugh, is it 211? Yeah. But do you understand what I'm doing? I just showed that x minus 3, x plus 2, x minus 3, x minus 2, x plus 2, and x plus 5, none of those are factors. I mean, there's still technically infinitely more that we could check, but we figured out that none of those work. Why did I say none of them work? What would need to happen for them to work? I would either need a remainder of 0 or a plug in and get 0 because they mean one and the same. So yeah, 57 was long, but hopefully the idea wasn't complex. I should say complicated. Complex has a mathematical meaning. Number 81, why didn't we like him? Ooh, he was kind of nasty. Here's a question. How many of you like synthetic more than long division if both of them are legal to use? How many of you guys like synthetic more? Like this? Oh, wow. Okay. For those of you that like synthetic more, you got to this problem and you were kind of like, because what does it say? You can use synthetic. I mean, yeah, you can use long division, but we already knew that. You can always use long division. But it says you can use synthetic, and over half of you said you like it more. So you would have gone to do synthetic, or you would have thought about it and said, how do you do synthetic with x minus 3? Remember how I said this is called a factor, and this is the solution? A solution. What's the solution? Even though it's not a normal x minus or x plus, it's a 2x minus, you can still add the 3 and divide the 2. Some of you are like tapping out, long division, I'm done. Nope. But if you like synthetic division that much, you can try the 3 halves. And it should work to get you the exact same thing as the long division. You have your 4, your -8, your 1, and your 3. Just the journey forward on this one, you have to be a bit brave and not mind fractions. But it's not all that bad, because if I multiply 4 over 1 times 3 over 2, doesn't the 2 and the 4 reduce and you end up with 6? And then I end up with, hey, 2 over 2 reduces and I end up with -3. And then -2 over 2 reduces and I end up with a -3 again. And then, what does that mean? Okay, it didn't tell you to show what it means, but what that means is that expression is technically equal to 4x squared minus 2x minus 2. And if I just multiply that on the other side, aren't I well on my way to getting the factors, guys? I know. I have an agenda. But I've told you my agenda, I'm not hiding it. The agenda is you guys being able to do section 2.5 where you're given something gross and you're supposed to figure out its math. But anyway, that was just kind of letting you guys know, yes, you can do synthetic with any linear pair. It doesn't have to be a 1x minus or plus an a. It can actually be a 2x, 3x, 5x, 7x, and ax minus b. You just have to always get the solution before going to your box. Does that make sense? Good, good, good. Wait, do you need me to talk through the steps or just show me, or show you? Okay. So then I'm going to do 2x squared to get 4x cubed minus 6x squared. What am I going to say right now? I'm a broken record on this. What am I going to tell you to watch out for, beware of? Distribute the negative. Some of you are doing it like in your head. I'm just saying be careful. And some of you are kind of showing it and kind of not. It might mess you up. I'm just going to do that. 4 minus 4 is 0. Negative 8 plus 6. And negative x will do the trick. And I need to make them match before my subtraction. Plus. That will cancel. I have x minus 3x would be negative 2x plus 3. And I see a negative 1. That negative 1 would get me my negative 2x plus 3, which subtraction goes in evenly. Wait a minute, this is weird. Why are the answers different? This one has 4x squared minus 2x minus 2, and this one has 2x squared minus x minus 1. So wait a minute, when I do this nifty solution thing, so thank you so much for bringing that up. I should have double checked and done it both ways. When we do this nifty 3/2 thing, it doesn't match right away. Can I show you why? Doesn't this point to, thank you, doesn't this point to that? Is this the exact same as that? Now is it? Check it. 2x minus. So this is that with a 2 factored out. That gets us into a little bit of trouble then with my answer, right? Because when I did synthetic division, technically this answer is for just x minus 3 over 2. So if I need to, oh, that's a problem. Well, that's okay. We can still do it though, but just check it. We have to go ahead and write this as 2 times x minus 3 halves. See if I can erase that real quick. Which, do you guys see the relationship between the two? Because if I was to take this final solution and if I was to factor out a 2. Yeah, I forgot. You can't always just throw that solution. The solution is what goes in the box, and it does get you what you need. The problem is it might get you a little extra beyond what you want. Thanks, Leigh, for showing that. So because of that little x minus 3 halves, stink. I have 2x minus 3. They're not the exact same. They do have the exact same 0. But when I do synthetic division, I am specifically doing the solution of the form x minus a. That's my bad. I totally misspoke. So when you get the answer, all my kids were like, okay, sweet, I can do that. And that's my final answer. We have to factor out the 2, just like we had to factor out the 2 from the 2x minus 3. And then we get our final solution. But to be honest, come on, how many of you guys were too scared by the 3/2 to even go for it? Yeah. So all of that to say, thanks, Wayne. The long division will get you straight to your answer. Why is it talking zero? The long division will get you straight to your answer. Whereas if you do want to do synthetic, whenever you have a coefficient in front, you do have to factor out that coefficient and realize when you do your synthetic, you're going to have to factor it out at the end as well. That's no fun. Thanks for asking about 81. I would have probably just done the synthetic and been like, it doesn't match. What on earth? But it's just that extra 2 that's been distributed in. Nasty. Okay. Anything else on homework 57, 81? We checked off both of those. We good? Ish? Good-ish? We don't look super ecstatic like we rocked it, but we're not all raising our hands trying to ask me things. Okay. Let's go have fun with 2.4. Some of you are already having fun in the homework. But there are 2 places, count them, 2 places where you could get tricked into. And to be honest, I think that's it. I think there's 2. One of them is powers of I, and they both have to do with powers of I. So, powers of I. Who's I, by the way? Imaginary. And specifically, isn't he the square root of -1 too? Right? So I is equal to the square root of -1. The square root of -1 is equal to I. So quick recapping of what you should have seen last year. If you did have something like the square root of -4, right? How could you rewrite that? As an imaginary number? Right? Because the square root of 4 is 2 and the square root of -1 is I. So we have to think about it separately, the square root of 4 and the square root of -1. But if we're trying to write it as an imaginary number, I can. We haven't had any reason to yet, because we've been talking about real things thus far this year. We're not going to be applying imaginary numbers in any sort of like physics sense with electrical currents or anything. But we're going to talk about this thing called a complex number. A complex number isn't just imaginary. It's actually partially real and partially imaginary. Every real number can be written as a complex number. Every imaginary number can be written as a complex number. Complex numbers are the umbrella that include both. Because if I just had a real number, A, I could say A plus 0, I. If I just had an imaginary number, B, I could do 0 plus B, I. Every real number can be complex, or be written as a complex, and every imaginary can be written as a complex. But why don't they just put the 2 together? Like over here, if I have 7 plus 3i, why not just make it 10i? I only combine when my terms are blank, so I'm not combining real with imaginary. But can I combine real with real and imaginary with imaginary? Yeah, I can. So therefore, how would you guys simplify the first example? 12 minus 12 plus a negative I, or just 12 minus I, right? So 7 and 5, I put my real components together, and then 3 plus -4, 3i plus -4i. Doing that inner operation. Got him. So, we just saw if you add a complex number plus a complex number, you get another complex number. In math, that seems to indicate that complex numbers are what we call closed under addition. A complex plus a complex is still complex. What if subtraction is also working that way? What happens when we subtract a complex number by a complex number? -2. Distribute, yeah, we got to be super careful, that's subtraction, right? And I'm going to get plus 7i. So far, the biggest place I think we would have possibly made a mistake is right here. True? See what we could have done. But most of you, hopefully, are at least somewhat on the lookout for that mistake, right? Beware the distribution, distribute carefully, combine my terms. So it seems now that complex numbers are closed under addition and subtraction. If you add or subtract 2 complex numbers, you get another complex number. Let me show you an example, just really random, really quick, of something that's not closed. Let's see. Integers. Integers? Yeah. Integers. Nah, you don't have to write it down. Aren't closed under division. Can you give me an example of an integer divided by an integer isn't another integer? What are integers? Number, but what kind of numbers? Positive or negative whole numbers, right? Counting numbers. No decimals, no fractions, no weird radicals or pi's or e's or anything like that. So give me an example of when you divide one integer by another integer and don't get a new integer. Oh wait, that's a bad example, because integer over integer was integer. 1 over, yeah. Integer over integer is fraction. Integer over integer is a rational. So not that you guys have to memorize this whole closed thing, it's actually something in college math and with advanced proof, not geometry proofs, but advanced proofs. But this whole closed idea, it's kind of snazzy because you're kind of seeing it today. And so far it hasn't been a shock. It's like whatever, a plus bi plus a plus bi is an a plus bi, no big deal. Addition and subtraction is super basic. Remember, I told you it's going to get tricky as powers and division. So let's get closer to powers. Multiplying. What could die on this page? Seals were in danger over there. What's endangered on this page? Puppies. Because what do we got to do? But how? To each, aka FOIL, right? Now, remember, there is this whole, you can square a binomial. There's like a formula for it you can do. My distracted ones, remember your test grade. Shh, focus. A plus b quantity squared. There is a formula. We can do it. But we can also just FOIL it. But either way, we do end up with 16 plus 16i plus 4i squared. Uh-oh. Complex number times a complex number does not seem to be a complex number. Where's my a plus bi? It's missing. Who's I? Well, himself. That's kind of cool. I is I, that's all the I is. Yeah. But there's no other way of writing it, right? But if I have I squared, which is I times I, which doesn't seem very exciting. But can't I also square the, well, okay, hold on, let me change colors real quick. I'm going to show the work. If we were actually thinking about him, why is, because I'm going to tell you that complex numbers are closed under multiplication also, which means a complex number times a complex number is still complex. It doesn't look like it, but it is going to be. But it's not what you think it is, I don't think. What happens when we square root? So I squared is a real number?
Yes.
That's weird. So it's like imaginary 1 second, and then just multiply it by itself, and now it's real all of a sudden. Huh. It's like off and then on. Ooh, zeros and ones, computer programming, binary code. Oh. Switches off and on. Maybe there's an application to imaginary numbers besides just blowing your mind. Okay, IQ. Focus. Kind of awkward, huh? Okay, but isn't that what IQ truly is? So could we go ahead and could we actually do square root negative 1, square root negative 1, square root negative 1? I guess so. Doesn't sound very easy to do, though. Could I write square root of negative 1 cubed? Still not very nice. I mean, squared was nice. Maybe it would be nicer if I had an I squared times an I. Maybe not write all 3 of them at once or cube them all at once. Maybe just split it up and say, well, it's a squared and a single. What happens if I take a squared and a single? Don't I like the square root of a -1 squared? Wasn't that nice? And then I just have an extra dude. So what was I squared? Okay, so can I technically say that I cubed is really just -1 times I, which is -I? Okay, so far I have I is I. Okay, whatever, we know that. I squared is actually a coefficient, it's -1. I cubed is really an I also, but with a negative, so who on earth is I to the 4th? How could I rewrite I to the 4th? I cubed times I. Oh, we could. But why not I squared times I squared? Because what's nice about the I squared? Aren't they just numbers? 1. And what's -1 times -1? 1. Just +1. Oh my goodness. And we're going to come back to this and keep talking about powers of I, because what if I was to give you something like I to the 57th power? But for right now, before we keep talking about the powers of I, can we at least take what we see and say, oh, you are a complex number? With just reals and imaginaries? What can we do to this I squared then? Make a -1. Can't I make this 4 times a -1? Which is a -4, you guys are totally right. So is this a complex number? I say yes. 4 taken away from 16 is 12. You could factor it, but check it, guys. A complex number times a complex number eventually, after substitution simplifying, will be a complex number. Oh, I had before, okay. So 4 times 4 is 16. Plus 8 plus 8. 8i made my 16. And then 4i squared. So I did my first outer and so it was all 4. Sorry, my arrow wasn't very good at messing. It was 4 times 4. And then my 8 plus 8. 8 plus 6. Okay, let's go back to powers of I for just a second. Not that you're going to see them tons and tons and tons. Oh, the spacing is very awkward. Why do I have the I's keep going? Okay, we already talked about I and I squared and I cubed and I to the 4th. We have I is I, and that's all that I is. I squared, though, is a -1. I cubed is -I. I to the 4th is just 1. I put negatives in parentheses. That way if it's next to something, I don't forget and accidentally subtract. I multiply. I to the 5th, though. Why would it just be I again? And why am I actually going to rewrite this list entirely? Why does it repeat though? How?
Because you just take basically I to the 4th plus I.
I to the 4th times, but yeah, times I. And I to the 4th is just, so if I can just take away I to the 4th, which is just 1, I can just see what's left. So I to the 4th times I to the 4th is just 1, I is what's left. I to the 4th times I squared, well, I squared is what's left. I to the 4th times I cubed is what's left. I to the 4th times I to the 4th, 1 is what's left. So what if I give you I to the, oh, not 57, fine, 35. What if I give you I to the 35? If this pattern truly will repeat, and if I truly do every 4 powers of I, it's just going to repeat over and over and over again. Can anyone talk me through how do I figure out the 35 then? Multiples of 4? What do you mean? She's saying that I to the 32 is a perfect multiple of 4. And how much past 32 are we? 3. Because we have I to the 33, I to the 34, I to the 35, and then I to the 36 would be another multiple of 4, right? And what I'm just showing is, what if we were to keep writing by 4s? And if we were to keep writing by 4s, well, 32 would have gotten us here. We would have started over again. That's one way of doing it. So doesn't it end up in which space and which spot? Wait, you guys okay? Because if we kept going by fours, we'd have 4, and then 8, and then 12, and then 16, and then 20, and then 24, and then 28, and then 32, and then 36. Where's I to the 35? Right here. Isn't he in that third spot? And that third row is going to have what as an answer? Negative I. Now pause. Can someone think of a more mathematical way or just an alternate way? What's an alternate way of getting there without having to think about exactly where it falls in our listing of going by fours? Because the next one is 129. I don't really want to go out there. Divide? By what? Divide what? Oh, who was saying divide?
7 and 5. It's like multiplying I to the 7th and then 7.
But I don't know if I want 7 or 5. Don't we want to break it down by multiples of 4? What's another way of figuring out where this falls in my list without just literally thinking of listing out I powers forever? Divide by 4. When I divide by 4, we get 8. Don't we get to the same exact place? But what's here?
The remainder.
And why is the remainder the key? It tells me where it falls. You see? It tells me where it falls. So you guys, think of a way to figure out I to the 129. You can use my cool remainder trick, or you can use the think about listing it out. Where would I to the 129 fall? Ready, set, in your groups, keep it quiet. Don't just go shouting out answers. Maybe you're right, maybe you're wrong. But what would I to the 129 equal? It's either I or negative 1 or negative I or 1. Don't just give an answer, give a why. Don't just give an answer, give a why. I'm going to listen. Remember that Griffin and Aiden are also in your group. Kimia, remember that Nikki and Sadi and Kayla are in your group. I to the 129. Who is it? Who is it? I to the 129. Talk it in your groups and do they agree? Lucas, does Spencer agree? While you guys are pondering, I'm putting a question up on this board. If your group is done, I want you to quickly keep collaborating about the following. How would you simplify 1 over rad 3 or 2 over 4 plus rad 3? If your groups have a hypothesis as to what the answer is, and you have a way to solve it that everyone kind of agrees with whether or not they like it the best, it makes sense. You're just pondering, how would you simplify it? Square roots? Huh? Why are those guys? That would have been a weird decimal too, right? But what did it show?
How did we choose 32? So then the answer is just I.
That's our answer.
Oh, because the remainder.
How did this get us there? Alright, who's I to the 129?
I.
Why?
4 can go into 128.
4 can go into 128, and 128, actually doesn't really matter what it is, but we could say 32. How many is left over?
1.
So what do I do with that remainder of 1? And why is that my key? There's one more I, and one more I would plop it in that first column. So technically we'd have I to the 128, and then I to the 129 would be right back up here to the top. This would be our I to the 4th. This would just be equal to 1, so we start all over at I. Another way of looking at it is we could technically rewrite I to the 129 as I to the 4th 32 times with another I, and this is just 1, and 1 to any power is 1, and 1 times I is I. I have 128 plus 1 is 129. And any of the 4th powers are just 1. Okay, that's all good. But I said there were 2 things that were going to be complicated. 1 is powers of I, and 2 is division. 1 is powers of I, and 2 is division. I'm telling you a statement right here from the very beginning that complex numbers are closed under division also, which means if you have an A plus BI over an A plus BI, the answer should be an A plus BI. If you have an A plus BI over an A plus BI, the answer should be an A plus BI. But the weird thing is, if you guys look at these divisions right now, and technically I might sneak in one more. How about something like a 2 over 3i? I'll sneak in one more example. If you look at all these divisions, does it look like we can simplify them at all? And so we realize, wait a minute. She just told us the answer is an A plus BI. But it's definitely not looking like that right now. Isn't I the square root of a negative 1? Why did I put square roots on the board? Are you allowed to leave square roots in denominators? No. How do you get rid of the square root? How do you rationalize is a snazzy way of saying it. Don't square it. You don't have an equals. You don't have another side of the equation.
Multiply by radical 3.
Is that what works? Because then 1 times root 3 is root 3, and root 3 squared, what happens? Root 9, which is 3, right? Or the square root squared simplifies. Now, when we get to trig in chapter 3, this is a kind of important fraction, but we can get rid of a square root in a denominator by multiplying by, what did the wording say? Multiplying by 1 creatively. Common denominators. I can multiply something like 1/2 by 3 over 3 to make it a 6. Multiplying radicals by radical over radical. I can change it to what I want it to be by multiplying by 1 creatively. So I'm going to be multiplying by 1 creatively also when dividing complex numbers. So what do I multiply by? Well, what did this one say to multiply by? So if I multiply by I over I, am I changing the value? No. Because what's that value? Right here. Isn't that just 1? So if I'm multiplying by 1, I'm not changing the value, I'm just changing how it looks. So what's going to change when I multiply? Well, 5i all over I squared. Wait. I squared is square root squared. Isn't that just going to become a negative 1? And can't I make that a negative 5i? Hey, 0 minus 5i. I have a complex number. I just had to simplify my denominator. I just had to rationalize technically. So what do you guys think we would need to multiply by in this one? 2 over 3i. Okay. So if I multiply by 3i over 3i, multiplied by I, multiplied by the conjugate. Is 3i the conjugate? No. Oh. Do you think we could just multiply by I? What if I let's change this example over here and put a 2 in front? Would we have multiplied by 2 rad 3 over 2 rad 3? Not really. Couldn't we just do that and have the 2 in front just kind of along for the ride? Right? Same thing here. What happens if you just multiply by what the problem is? Isn't the problem just that I in the denominator? Why? Still 1. Am I allowed to multiply stuff by 1? It stays the same. Changes forms, but keeps the same value. Let's check it. Isn't that going to be a 2i over 3i squared? Oh, square root squared. It goes away, and I end up with just a -1 times 3, which still technically isn't a complex number until I make it -2/3 I. I can make it -2 over 3 times I over 1.
How come the I isn't also over 3?
Because technically this would be -2 over 3 times I over 1.
Got it.
But, guys, what happens if I try to do the same thing to this guy? Kind of like that bottom square root. If I was to do an I over I, wouldn't I have to distribute him? Yay, I squared! Boo, it's I again. You wouldn't get rid of the I if you distributed him to both. So what do we have to do instead? The same thing you needed to do there, which is multiply by the conjugate. Sorry, I'm doing it. Multiply by the conjugate. Now what's the problem with conjugates? Don't I have binomials now? Times binomials? If I have binomials times binomials, aren't I? Let's see, 6 minus 7 plus 12, that'd be plus 5i minus 14. Pause. Am I going to have a little bit of simplifying to do?
Yes.
Yeah. But isn't he going to be real? I'm going to say this is the problem. Get out of here. I'll see you guys later. Homework due tomorrow. That's the end. I'm just going to make it look pretty. You can check out the YouTube video if you need.